Hello friends, welcome to Vidyunmala. This is the third video regarding basics of chemistry laboratory. So in my previous video I told you that I'll make another video in which I will explain the different ways of expressing concentration of solutions. Let's begin. So we will express concentration in terms of percentage. We have three types of expressions like percentage weight by weight, percentage weight by volume, and percentage volume by volume. What do you mean by percentage weight by weight? Mass of solute by mass of solution in grams. So you have to express the mass of the solute in grams, mass of solution in grams multiplied by 100. If it is percentage weight by volume, mass of solute by volume of solution in milliliters multiplied by 100. If it is percentage volume by volume, it is volume of solute by volume of solution taken in ml into 100 ml or 100%. I'm sorry. So whenever you purchase a packet of oil, you find 1 kilogram of oil, or otherwise you ask the storekeeper like 1 liter of oil. When you turn the oil packet back and read all the specifications, you find somewhere that 1 kilogram of oil is equal to 980 ml, or 1 liter of oil equal to 980 grams. So this conversion happens by density conversion. So density equal to mass by volume, we know it. So if someone asked you to prepare 2% of some salt solution, how do you prepare it? 2 grams of solute by mass of the solution in grams into 100. So it is going to happen. Say for example, in another way, I have taken 2 grams of some salt and I dissolved it in 100 ml, 100 grams of water. What will be the percentage? So it is 2 by 102. 2 by 102 into 100. Why? Because you have to calculate mass of solution. What is the mass of solution? Mass of solute plus mass of solvent. What is the mass of solute here? 2 grams. What is the mass of solvent? 100 grams. So total is 102. So 2 by 102 into 100. That is the resulting percentage we have to calculate. So we'll get with one problem. Calculate the percentage weight by weight of a solution prepared by dissolving 15 grams of table sugar in 100 ml of water. The density of water is 1 gram per ml. So everything was just given to you. Just go through once. So the mass of the water used is 100 grams because according to density, each ml has 1 gram. So the mass of the solution is equal to the mass of water plus mass of the sugar. So what is mass of water? It is 100. What is the mass of sugar? That is 15 grams. So total mass becomes 115. So 15 divided by 115 into 100. So the percent is 13%. Let me once recapitulate it again. What is the mass of water? It is 100 because density is 1. So if you take 100 ml, mass also becomes 100 grams. What is the mass of table sugar that was taken? 15 grams. So what is the total mass of the solution? Mass of the solution equal to mass of the solute plus mass of the solvent. Mass of the solute 15 grams, mass of the solvent 100 grams. So totally it is 115 grams. So then what is the percent weight by weight? Mass of the solute by total mass of the solution into 100. So 15 by 115 into 100, and the percent is here 13%. So now we'll get with another problem. What is the percentage strength of a solution of urea if 80 ml of solution contains 12 grams of urea? So percent strength, percent, which means x by or 1 by 100, 1%. What do you mean by 1%? 1 by 100. 80%, 80 by 100. So here x percent, because we don't know what exactly percent, we got here per 80 ml. So 12 grams is present in 80 ml. So how much will be present in 100 ml? So simply 12 into 100 by 80, and that gives you 15%. So somebody will ask you what is the percentage of marks in some subject. You say 75%. That means the total marks for the subject is 100. Out of 100 you got 75. Your percentage is 75. Okay, I think I'm clear with this particular example. Say if you want to prepare 2% table salt solution, how do you prepare? Very easy. You have to weigh 2 grams of table salt, dissolve the 2 grams of table salt in 100 ml of water. That results a 2% solution of table salt. Problem 3. This is what I explained you, so I don't need to explain again. 70% of isopropyl alcohol, 70 ml of isopropyl alcohol, that is solute, 30 ml of water, that is solvent. So total volume becomes 100, 70 by 100. So to express concentration, we have other terms like molarity. Molarity is defined as the number of gram moles of solute present in 1 liter of the total solution. So molarity is defined as the number of moles present per liter of solution. So if you wish to write it mathematically, molarity equal to number of moles by volume. You can represent it as N by V, small letter n, lowercase letter n by V. So molarity equal to N by V, where number of moles can be calculated by using the formula weight of the substance by gram molecular weight of the substance. So to calculate molarity, we have a formula like molarity equal to weight of the substance divided by gram molecular weight of the substance into 1000 by V in milliliters. If it is in liters, 1 by V. If it is in milliliters, we write it as 1000 by V in ml. Say if you here you find 3 terms. One is molarity, then weight of the substance, then volume. If any one of the three to be calculated, the rest is known. In a problem, you will be given molarity, you will be given volume, you will be given the substance, you have to calculate the weight of the substance, or vice versa. Then it comes for normality. Normality is defined as the number of gram equivalents of solute present in 1 liter of solution. The number of gram equivalents of solute present in 1 liter of total solution. So normality is equal to number of gram equivalents by volume of solution in liters. So you can represent the same in another way. Normality equal to weight of the substance by gram equivalent weight of the substance into 1000 by V in ml. Then how do you calculate gram equivalent weight? It's not a simple formula to calculate gram equivalent weight. We have different formulas. If you wish to calculate the gram equivalent weight of an acid, the formula is gram molecular weight of the acid divided by basicity. What do you mean by basicity? Basicity is defined as the number of replaceable hydrogens in an acid. Say you were given HCl, how many hydrogens are there in HCl? 1. That can be replaced. So the basicity of HCl is 1. The basicity of H2SO4 is 2. Vice versa, you can go through. Then gram equivalent weight for bases, same, GMW of the base divided by acidity. Say for example sodium hydroxide. How do you define acidity? Acidity is the number of replaceable hydroxyl ions or hydroxide ions. So in case of sodium hydroxide, it is 1. So 40 by 1. Then gram equivalent weight for salt. Salt is a combination of acid and base. So salt, we have 2 terms, cation and anion. Each of the cation has a charge. Each of the anion has a charge, but it should be neutralized. Say for example NaCl. The charge on sodium is +1, the charge on chlorine is -1. So when these join together, Na +1, Cl -1, that particular salt is electrically neutralized. Okay, so if you want to calculate GeW for a salt, the formula is gram molecular weight by total charge on cation or anion. Why I use the word total charge? Because we have a substance called sodium carbonate. The chemical formula is Na2CO3. Here we have 2 sodium ions. Na, always sodium possesses +1 charge only, no? So we have 2 sodium ions, that is 2 multiplied by Na +1. CO3 carbonate carries a bi-negative charge, -2. CO3 is -2, 2 Na plus. So 2 into +1. Hence the word is total charge on cation or anion. It becomes +2 or -2. So we will remove the sign. We'll just add the numerical here. 106/2. If it is a redox system, where electrons are transferred from one to another, then gram equivalent weight for a redox system is GMW, gram molecular weight, divided by number of electrons transferred. Here this is very important. Redox reactions are always favored in a particular medium. Say the redox reaction between iron and chromium 6 happens in acidic medium. So in acidic medium, 6 electrons will get transferred from potassium dichromate, from chromium 6. If it is the case of manganese, a very typical example, KMnO4. KMnO4 in acidic medium, 5 electrons are transferred. In neutral medium, 2 electrons are transferred. In alkaline medium, 4 electrons are transferred. So you have to keep in mind what is the reaction medium where the reaction is happening. This is the way you have to calculate the gram equivalent weight. After calculating gram equivalent weight, you have to calculate the normality of a particular solution. Then mole fraction. Very simple. We have two components in a solution. One is solute and the other is solvent. You have to calculate mole fraction for the solute, mole fraction for the solvent. You know what is number of moles. Number of moles is equal to weight of the substance by gram molecular weight. So if you want to calculate for solute, X solute equal to number of moles of solute by total moles of solution. If you want to calculate for solvent, number of moles of solvent by total moles of solution. X solute plus X solvent equal to 1. Simply we can say it as X solute equal to solute by solution. What solute? Number of moles of solute, N solute. So N solute by N solution. If it is for solvent, N solvent by N solution. So total becomes always 1. So this is about ppm. Whenever you wish to express very dilute solutions, you will always be going through ppm, which can be mathematically represented as ppm equal to weight of the substance into 10 power 6 by weight or volume of solution. So here, why 10 power 6? Because it is in million. You have to express in million. Then the fifth item is molality. Molarity is represented by capital M. Molality is represented by small m. Only the change is you have to express in terms of weight. So weight of the substance by gram molecular weight into 1000 by weight of the solution or weight of the solvent. This is what about calculating molality. Whenever you go for a chemical laboratory or laboratory where we do experiments with chemistry, you find such bottles. Those are called as reagent bottles. Those are named as reagent bottles. Or you purchase these from your chemical stores. Say you have XYZ chemical suppliers. From those suppliers you will find everything is written on those particular bottles. Specifications, we call them as specifications. You observe it, sulfuric acid 95 to 97% pure. It was not mentioned what is the concentration. You have to calculate the concentration of such a bottle. Do you calculate? You will be calculating by using a formula, and the formula is weight of the substance per liter of solution multiplied by purity divided by molecular weight. Weight of the substance per liter of the solution multiplied by purity divided by molecular weight. How do you calculate weight? To calculate weight, we have to know about density. But for a particular solution like sulfuric acid, we were not given density. We will be given specific gravity. What is specific gravity? Specific gravity is the ratio of density of the substance by density of reference. Density of reference. Mostly water is taken as a reference. So if you know the specific gravity, if you know the purity, you will be calculating the molarity. For sulfuric acid, which you purchase from a supplier, the specific gravity, it will be there on the specifications as I shown previously. It is 1.8. GMW is 98, percentage purity we have just seen 98. So just substitute all in the formula, specific gravity multiplied by purity into 10 by GMW. So 1.8 into 98 into 10 by 98. So the molarity of sulfuric acid which we purchase from particular suppliers is 18 molar. It is not same for all. Say I purchase from XYZ, you may purchase from ABC. Whenever you purchase from ABC, you have to read all these specifications. You have to write down the specific gravity. You have write down the percent purity. Then substitute the values in the formula and you will be calculating the molarity of the solution which you have purchased. I hope I'm clear. Thank you.